so notes on vectors and parametric equations, and the first vocabulary word is velocity, right? And actually, guys, let's make it a little bigger. Okay, it gives you a definition for velocity. It says a velocity is a vector that specifies the motion of an object in terms of speed and direction. Because all velocity is what you were doing all day yesterday, okay? A velocity is just, it's a vector. All right, that's all that it is. But today we're going to talk about vectors and their speed. Well, yesterday you found speed as well when you found magnitude, right? Do you remember finding magnitude? Okay, so the magnitude is the same thing as, what was it? When we found magnitude, what were we actually finding? Do y'all remember? I heard it. The length, okay? It's the length, which is also the speed. Those are all the same things. If you've got a line and you want to know how far it's going, okay, that's the same thing as the speed, okay? Or the length, or the magnitude, they're all the same thing. And the last vocabulary that's kind of important, and it kind of explains and links this together, all this physics, you think you were in a physics class, right? It says, speed is the distance traveled by an object in a particular time. Okay, so speed is the distance traveled in a particular time, and velocity is the speed in a particular direction. So the reason velocity is so important is velocity not only tells me how far I'm going, but where. Like, I'm going to take, for example, the problem we used a lot yesterday was we did P to Q, right? Which was 3, 3. Okay, so we did P to Q, which was like 3, 3. That meant we went 3 right and 3 up, correct? Okay, it tells me where I'm going and how I'm getting there. So here is a vector equation. This is an equation that has been derived by whoever. I'm probably a physicist, because this is where you use, vectors mainly. Okay, a ship would use a vector, an airplane would use a vector. There's a really funny quote from Top Gun, that they're talking about airplanes use vectors. Okay, that's where they're from. It's to measure an airplane. You want to know, okay, not only which direction am I going, but which direction and how fast, so that you can find that airplane at any time. Right, when they were looking for that Malaysian jet, right, that didn't work very well, did it? Okay, their vector applications weren't working, okay? But that's what they're doing. They're gonna find the trajectory of a plane or a boat, and it'll help you decide where you'll be along the way, right? Where you'll meet up with somebody and when. That's what this equation is, okay? So let me explain the parts of it. This x, y, right here at the beginning, that just defines your values. We're gonna be talking about x and y, location. Where am I on the x-axis and where am I on the y? So this right here defines your variables. Okay? And then what do you think x0 and y0 mean? What would a 0 mean? If you're talking about a boat or an airplane, the 0, this first point right here, what would a 0 mean? Yeah, it's initial point. So this point right here, the first one that it gives you, okay, is its initial point. But it's going to put it in vector form. Okay? Its initial point in vector form. So that first vector you see is where that boat or that airplane or that whatever we're talking about in this terms starts. Okay? Now then, the next one is T. What do you think T stands for? Time. Okay, and this last one, A, B, it's the most important, you'll use it the most, is the velocity. Okay, so you have it all written down, right? So let me talk to you again about it now that you have everything identified. So if I want to measure where an airplane is, okay, walk through this with me for a second. This first point is where I start, okay? For example, let's say you start at 0, 0, okay? Then this T means how many times you move. And this last point means how much you move. So for example, if we're gonna use 3, 3 like we talked about yesterday, if I start at 0, 0, in one jump I'll be at 3, 3, correct? But what if my time was 2? What if I made 2 jumps? I wouldn't be at 3, 3 anymore. Where would I be? 6, 6, right? What if I wanted to find out where I was in 10 jumps? What would I multiply 3, 3 by? 10. So that's why it means multiply. T is time times however many jumps you make. Okay? That's kind of what the formula means. Where you start times however many times you make your jumps. All right? Now, down here. So that's the vector equation. I've explained that to you. And we only have one last new thing. The last new thing is something called a parametric equation. Okay? And a parametric equation is just a way to define x and y in terms of time. This is an equation that allows you to find the exact location of an object, okay, at any given time. Right? It doesn't do me any good to know I'm at 4, 4 if I don't know when I'm going to be at 4, 4. Right? So this is what they've derived. Watch for a second. Okay, and I'll explain the formula to you. Okay. If I want to find the x value, I'm going to talk about the x right now. If I want to find the x value, the formula is x0, which is right here, where you're going to start. Agree? I'm matching it with this one. X of 0 is where you're going to start. And you're going to add to it, which of these pieces is the x value, the A or the B? The A. Excellent. So you're going to say, all right, my initial point plus however many jumps I make times however many jumps I do that for, right? So if I'm jumping 4 3 times, I'm going to do 4 times 3. Now go to the y. If you want to figure out where your ship is as according to the y value, then you use the other part, okay? Here's your y value. Here's your y value right here, your initial. In other words, this is your start, wherever your y is going to start. And then you add to it this amount, b, because you, however many times you move b. That's how you find x or y. Right, so flip it over and let's do a problem and see how we do. Go to the 2 new vocabulary words, guys. Remember our vector equation, which we have highlighted, and then you have a parametric equation. The parametric equation just puts everything in terms of time. So these are 2 new things. All right, so let's read number 1. We can use a vector and parametric equations to describe a motion in a coordinate plane. So number 1, the vector equation, right, and it gives it to us right here, is this. Okay, remember from what we learned that this 3, 6 is the initial point. Agree? And what do we call this negative 2, 1? What was it called? What do we name it? The velocity. In other words, how fast we're going. We're going to start at 3, 6, and we're going to, okay, look at me so you can see this. We're going to start at 3, 6, and we're going to go left 2, and what are we going to do with this 1? What's the 1 tell us to do? Up 1. Left 2, up 1. So we're going to start at 3, 6 and go left 2, up 1. Left 2, up 1. Left 2, up 1. Right? So if you're going to draw a picture of that, just to see a picture one time, let's look at a picture of our vector. Okay? So graph it. We're going to start at 3, 6, which is here. This is our initial point. And then it tells us that from that point we're going to go negative 2, 1, which would mean left 2, which would put us at 1, and then up 1, which will put us at 7. So 1, 7 is the next point. So every time you make a hop, you're going to land on that line. Right? Right? If you go forwards or backwards, you're going to land on that line somewhere. Okay? So the directions say, find me the velocity and the speed of the object. Because you just look at it. What's the velocity? We already know. Which of these tells me the direction of the point or the line? Right, so the velocity, write down the word velocity and you just look at it. It's negative 2, 1. It's that easy. It means that our ship, or whatever it's talking about, our equation, is going left 2, up 1, left 2, up 1 every step. That's why it's called a velocity and not a point. This is a motion, left 2, 1. It's not at negative 2, 1, right? If we go to negative 2, 1, are we on the line? No. Do you see what I'm saying? It's not an ordered pair. It's a direction. Okay? Now then, it also asks us for the speed. To get the speed, what do we do to this? We find the magnitude, which is what we did yesterday. So you're going to find the magnitude of negative 2, 1. Right? Which just means you take the square root of 2 squared, which is 4, and of 1, which is 1. So the speed of that is root 5. Okay? Now the thing that we haven't done yet is it says write 2 parametric equations. Do y'all see that? Write 2 parametric equations. We've not done that yet. Okay, if you go to the other side, okay, and take a look at what our parametric equations look like. It was defining x and defining y in terms of t. Correct? So go to your equation, right, which is up here. And remember x equals. Okay, where does x start at, guys? Look at your vector equation. Where did x start? At 3. And then it hops left 2 every time, right? So then we're going to go minus 2 every time, each motion of time. That's x. Now try y. Look at y. Where does the y value start? What's the initial point of y? 6. Okay, and it's going to do what? What's the y value here? It's just 1, so plus 1 every jump. So there are your parametric equations. Right? It's easy. Okay, so now let's go to number 2. Given the vector equation, here it is, and the 2 parametric equations, it gave us parametric sum. We didn't have to find it. Right? Find the following in regards to an object traveling at a constant velocity. Okay, step 1, find the velocity and the speed. So let's do that. Find the velocity. Bless you. Where do we get the velocity? What do we look at? Just this last part, right? What's the velocity? We're going to go left 3 and up 2 every time. Now let's find the speed of the object. In other words, we're going to go left 3 up 2, left 3 up 2. Well, at what speed? Okay, and to find that, we find the magnitude. Remember, negative 3, 2. Which is just going to give us the square root of 9 plus 4. So the square root of 13 is the speed. Be sure to write velocity equals speed equals. That way you know the difference. Okay, part B is the only thing new. This is it today. B is the last new thing you're going to learn. Okay? Now, when and where does the object cross a line? When and where? So you have this line that's going at this highlighted rate right here. Okay? We've got a line that's starting at 2, negative 1, and it's moving left 3 up 2, left 3 up 2. And I want to know when that line, let's just pretend like maybe this is it right here. I want to know when this line is going to hit another line. Or in real life, what that is saying kind of, it's like saying, all right, I've got a boat going this way and a boat going this way. When are they, at what moment in time would they intersect? When do I need to change my route, right? Okay, or maybe there's a barrel there or an oil spill there, okay? You want to divert it. Or if it's an airplane, maybe there's an airplane there. When would I hit that other airplane? When do I need to change my vector, my route? Okay? So that's what this is at. Physics does this, okay? Air traffic controllers do this, well, computers do it. But someone has to understand the concept so that the computers can be programmed, right? So that's where it's coming from. Now, so I'm asking when and where. So the way you do this is when is time, isn't it? Which of these things is put in terms of time? Where do we deal with time? we dealt with time right here on the parametric equations, right? So if I want to find time, then what you do is you take this, okay, and you plug in these two things instead. You're going to write x in terms of time. So instead of x, I'm going to say, okay, I know x is done by taking 2 minus 3 jumps every time. That's the same as x. And then y is taken by doing -1 plus 2 times every time. And what does it equal? 2. Excellent. So if you look at your equation now, guys, I have everything with only one variable. What's the variable? T, time. So solve for time for me. Okay? So then you're going to put the t's together. A -3 and a 2 make -1t. And then 2 and -1 make 1 equals 2. I'm solving for time. So move the 1 over. If you divide by -1, then the time is -1. Okay, now that throws a few people off. Wait a second, how can time be -1? Hey guys, think about it, it's a line. So instead of going forward on the line, it would have hit behind. So if the boat turned around and went the other way, in one step, it would run into it. Do you see what I'm saying? Okay, so time is just meaning a continuum on the line. It can be negative. Now then, the next thing, so we found when. That's in t equals -1. Now it wants where, right? To find where, if time is -1, how could you find x and y? Where could you plug the time in to get x and y? Into your what? Yeah, into your parametric. So plug in parametric, plug into your parametric to find when. So your parametric equations say x equals 2 minus 3 times my time. My time is -1. So my new x starts at 2, and I make a jump of -3 times -1 time. In other words, backwards, right? That means it's going to put me at a location of 5. So x is 5. Now how are you going to find the y value? Go back and look at your parametric equation again. The y value starts at -1, and I jump up to, but I'm not going to jump up to, I'm going to jump down to necessarily, right? So multiply that times my time, which is -1. When you plug that into your calculator, you get -3. So the way you write your answer is this boat traveling at this velocity right here, at this vector equation, okay, starting at 2, -1, and traveling -3, 2, is going to intersect this x plus y equals 2 line at a time of -1 at the point 5, -3. So at 5, I'm sorry, you can't see that. At a time of -1 at the point 5, -3 is where the line intersects the ship. You've learned everything. There's nothing new now. Okay? So we're going to apply all that and do one more problem together. We're only going to do number 4, not number 5. I'm sorry. We're going to do 3 and 4, not 5. Okay, number 3. I'll give you a second to read it to yourself. Now, it gave us a parametric equation, in other words, a route in which your, this time instead of ship, yeah. So you got a ship, and your ship is traveling on this route. So that you understand it better, guys, it means I'm starting at 6-1, and I'm traveling right 2 down 5, right 2 down 5. You got that? And along this line somewhere, the coral reef is represented by this line. Okay, and I want to know when the ship is going to be at the coral reef. So the first question is, find the two parametric equations. That's the easy part, right? That's the x equals and y equals. Those are the parametrics. So x equals, where do we start at? 6, right? Plus 2 times every jump, 2t. Now you find the y equals. Y equals, where's y going to start? Where does y start? 1. And then you're going to go down 5 every time. So there's your parametric. The next step then is find the velocity and the speed of the ship. Velocity and speed. Okay, the velocity is the easy one. You just look at the parametric equation. Looking at this equation up at the top, what's the velocity? Remember, it's this one. This is my initial point, and this is where I'm traveling x and y. So it's 2, -5. Then it asks for the speed. And remember, the speed is just the square root of 4 plus 25. You square both of these, the a and the b. So the speed is the square root of 29. And the velocity is left 2 down 5, left 2 down 5. All right, now the last part, C. When and where will the ship come in contact with the barrier reef? When and where? So when is time, correct? Okay, this is the step where, go back and look at your notes before. Okay, you go back. When it asked me about when and where, my directions, what did I do? What did you do? You plugged in the parametric equation, right? So let's go do that. If you forgot, you can write yourself a note. Plug in parametric equation to the line. Okay, now the line is 2x. So I want 2 x's. So 2 times, we're going to plug in what x was, which is 6 plus 2t. Then I want plus y, or y is 1 minus 5t. And it says it equals -6. What do you think my first step? This is just a plain old equation from 8th or 9th grade to solving this equation. How do I solve for t? What step do I need to take first? What do I do first? Distribute the 2. So 12 plus 4t plus 1 minus 5t equals -6. Combine your t's and solve. Find t. Okay, 4 and -5 make -t again. 12 and 1 make 13 equals -6. If I move my 13 over, okay, here, I ran out of room. You get -t equals -19. So what's t equal, guys? 19. So your time is 19. So there's my when. How do you find where? To retake this and plug it into your parametric. So to find where, well, I know x starts at 6 and jumps 2 for every amount of time. Well, how many times am I going to jump? I'm going to jump 19 times. And to find y, well, y starts at 1 and it goes down 5 every single time, which is 19 times. If you're wondering where I got these are my parametric equations. They came from A. Okay, to find out where, you plug your time into your parametric equations. So if you type 6 plus 2 times 19 in your calculator, you get 44. If you plug 1 minus 5 times 19 into your calculator, you get -94. So in 19 jumps, you're gonna be at 44, that's an at symbol. So T is 19 at the point 44, negative 94. Okay, now then, do me a favor, and I'm gonna pass out your homework, and I want you to do 1, 2, and 3, and all 3 are due tomorrow for grade, okay?